All right, so we're going to start on sequence and series today. These are general sequences and series. And then we get into something called arithmetic and geometric, which are special kinds of sequences. The sequence is basically a number of terms. So like it'll say like the first 5 terms in this sequence. So you're listing terms in a sequence that have some sort of a pattern. And then series will lead into summation. So like it will say the sum of the first 5 numbers or the sum of this kind of thing. And that's like basically the next 3 sections. So a sequence, it says an infinite sequence is a function whose domain is the set of positive integers. So infinite means it doesn't end. And when it says positive integers, it means like the number on the base of these. So A1 is the term in the first spot. A2 is the term in the second spot. A3 is the term in the third spot. You won't see something that says like A-1. So that's what it means by positive integers. It actually could be A0, which we'll get to in a little bit, but you won't go negative. Those numbers are called the terms of the sequence. Okay, again, remember infinite would go on forever, okay? And then if the domain of the function consists of the first n positive integers only, then the sequence is a finite sequence. So the difference between those two things would be, give me the first 5 terms in this sequence. Now that's finite. If it said the terms of this sequence and it goes on without ending, you'll get the dot, dot, dot at the end. That's an infinite sequence. So for example, even numbers. Even numbers would be an infinite sequence, right? It goes 2, then 4, then 6, then 8, and it goes on forever without ending. But if I said the first 5 even numbers, now it's a finite set. All right, so this first one, literally, we are simply just finding the terms in this sequence. So it says, write the first 4 terms of the sequence, and we're going to assume n starts with 1. So the way you will see this written is it will say A of 1. And the 1 is the number you plug in to the n. So 2 times 1 minus 4 is 2 minus 4, which is negative 2. Then I find A2. And I plug in 2. 2 times 2 minus 4. 4 minus 4, which is 0. And I plug in 3. 2 times 3 minus 4. 6 minus 4. Which is 2, and I plug in 4, 2 times 4 minus 4, 8 minus 4, which is 4, say first 4, and those are the first 4 terms of your sequence. Usually you will list them in order that you got them, so we don't rearrange them by size or anything like that. We list them in the order that we got them, separated by a comma, so it would be like negative 2, 0, 2, 4. Unless it says A1, A2, A3, and then obviously you just plug those values in. All right, you find the first 4 terms of the sequence for B. All right, so A1, now there's 2 n's, but you put the 1 in both those spots. Okay, so 2 times 1 over 1 plus 1, 2 over 2, which is 1. Then A2, 2 times 2 over 2 plus 1, 4 over 3. A3, 2 times 3 over 3 plus 1, 6 over 4 becomes 3 over 2. And A4, 2 times 4 over 4 plus 1, 8 over 5. And then these are the first 4 terms in your sequence. Easy stuff, right? Yeah, questions? All right, they just get more complicated. So now it says the first 5 terms of the sequence. So I'm going to do A1 equals negative 1 to the first times 1 over 1 plus 1. And I get negative 1 times 1/2, which is negative 1/2. And then A2, negative 1 squared. 2 over 2 plus 1, which is 1 times 2/3 or 2/3. Then I go A3, negative 1 to the third, times 3 over 3 plus 1, negative 1 times 3/4, negative 3/4. And then a4, negative 1 to the 4th over 4 times 4 over 4 plus 1, which is a positive 1 times 4/5. And last one, a5, negative 1 to the 5th, 5 over 5 plus 1. All right, questions on these? Okay. Is that we're going to eventually have to like determine a pattern from looking at like what is the pattern that would get you these terms. And notice that what's happening with these numbers, like look at the signs, right? It goes from negative to positive to negative to positive. So one of the ways to change signs is by multiplying times negative 1 to the n power. So if it's negative 1 to the n power, it's going to give you a negative number. If it's negative, to an odd power, if it was negative 1 to an even power, it's going to give you a positive there. So that's one way. If you see your signs changing from positive to negative, that's one way for it to happen. The other thing is notice that my numerators are increasing by 1 and my denominators are increasing by 1. So if you see the n over n plus 1, that's one of the ways that can happen. So there is questions in which you're going to have to figure out your pattern. And sometimes paying attention to stuff like that is helpful. All right, example 3 says find the indicated term of the sequence. So now we're jumping to just one specific term. It gives you a sub n and then it asks for which one? It asks for a4. So I'm literally plugging in 4. So 4 to the second over 2 times 4 plus 1, which is 16 over 8 plus 1, which is 16 over 9. You cannot reduce that. Everything's because they're both perfect squares. You can reduce that, but you can't. Those are not divisible by the same number. So you'll leave it just like that. I don't need you to put these in mixed number form. You're not going to approximate. You're never going to round these. You're going to keep them exact. Right, Sam? All right, so this one says write n, it should be an, not and. Write an expression for the apparent n term of the sequence. This basically means come up with an equation or an expression that would give you these as the results, okay? So if I look 0, 3, 8, 15, 24. I'm not saying like find me something that gets from 0 to 8 and 8 to 3 and 3 to 8 and 8 to 15. So you're not thinking that way. You're thinking if A is 1, how would I get a 0? If A is 2, or n, sorry, is a 2, how would I get a 3? If A is 3, how would I get 8? If A is 4, how would I get 15? And if A is 5, how would I get 24? The same way. So I have to use the same equation. So more, like less than look from 0 to 3 and 3 to 8 and 8 to 15. Look from these n values. How would I get from 1 to 0? And then can I do the same thing to get from 2 to 3? So this is, to me, this is the hardest part of this lesson because there's not like a step 1, a step 2. You have to identify a pattern. So if I look, like first of all, what ways can you get from 1 to 0? I could subtract 1. I could, multiply by 0, but then they'd all be 0, right? So if I subtract 1, then it works for A1, but does that work for A2? No. So that pattern doesn't work. So what else can I do? Square it and subtract 1. Okay, so if I square 1 and subtract 1, that gives me 0. If I square 2 and subtract 2, does it give me 0? Does it give me 3? No, if I subtract 2, it doesn't give me 3. But if I subtract 1, now it gives me 3. So now we're saying this could be n squared minus 1, and let's test that theory out. This would be 3 squared minus 1, 9 minus 1, that's 8. This would be 4 squared minus 1, 16 minus 1, and that's 15. And then 5 squared minus 1, 25 minus 1, which is 24. So we've established our pattern, and you rewrite it in equation form. So a sub n equals n squared minus 1. What? What's changing?
It's becoming a fraction.
Okay, so if it's
pattern is a strategy in which students look for patterns in the data in order to solve the problem.
Pretty
Students
accurate.
look for items or numbers that are repeated, or a series of events that repeat. This is from teachervision.com.
so helpful. So the thing is that it's a fraction. Yes, so I need two separate things. I need something happening in the top and something happening in the bottom. What else do you see? All of the numerators are increasing by 1 and all the denominators are increasing by 1, okay?
By 2.
Are you comparing them to the term number?
Yeah.
Yes. So if I look at A1, what do I have to change to get to 2, my numerator? I would add 1. And what would I have to add to n to get the denominator? 2. So let's see if that works every time. So A2 would be 2 plus 1 over 2 plus 2, and that's 3/4. That matches. A3 would be 3 plus 1 over 3 plus 2, which is 4/5, and that matches. 3 plus 2, 4 plus 1 and 4 plus 2, 5, 6, that works, and 5 plus 1, 5 plus 2. So we found the pattern that works. So this would be n equals n plus 1 over n plus 2. Now here's I would say the catch to these is that they're not always the same. So don't freak out if you get a different answer than somebody else, okay? As long as it still meets your pattern.
Is this going to be on the test?
There might, probably not by test time. There might be one on the quiz. Yeah. Okay, now a recursive sequence. So a recursive sequence is one that relies on the value of the previous term. God bless you. So we're saying take the last term that we just got and do something to it. To define a sequence recursively, you need to be given at least one or more of the first few terms. So you have to have a term to start with. Recursive, again, recursive just means take what you just got from the last one and do something to it. Add to it, subtract from it, multiply it by something, whatever it is, but you have to have a starting point. What's weird and throws people off is the notation on this. So this A1, let's say it's 5 this time. This is saying AK plus 1, which means take the one before it and add a number to it. So if I said A1 was the first one, A2 is the next one, which would be K plus 1. Then it says take AK, which was the one before it, and add 10 to it. So if I take 5 and I add 10, I get 15. So then A3 is saying go to the one before it, which is 15, and add 10 to it. That's 25. Go to the next one. Go back to the previous number and add 10 to it. That's 35. So each time here, you're adding or subtracting or multiplying by the same thing. So this time is increasing by 10, but that obviously could change. Just don't be scared by that notation. It's called recursive, but it just means use the number before it. So example 5 says, write the first 5 terms of the sequence defined recursively. So the first one is 15. The second one would be 15, the number before it, plus 3. What's 15 plus 3? 18. The next one says go to the number before it, 18, and add 3. You get what? 21. The next one, go to the answer from the previous answer, 21, and add 3 to it. You get 24. A5, go to the one before it, add 3 to it, and you get 27. So the first 5 terms of this sequence include the one they give you because that's A1. Be careful there because that's a mistake people make. So it would be 15, 18, 21, 24, and 27. Questions on that one?
What is the A, K plus 1?
K plus 1 just means the number, like the term after the previous one. That's all. So if the first one is K, then the next one would be K plus 1. Then that one becomes K, and the next one is K plus 1. Does that make sense? So you're always going just one after it. K is just a constant, so it could be anything. All right, example 6 says, write the first 5 terms of the sequence defined recursively. Use the pattern to write the nth term of the sequence as a function of n. So let's start with the first part. Write the first 5 terms of this sequence. So what are we going to do to each term every time? Multiply by a third or divide by 3, right? So if the first one is 81, what's the next one? 27. What's the next one? 9. What's the next one? 3. What's the next one? 1. So first 5 terms include the first one that we had because that's 1. So it's 81, 27, 9, 3, 1. That's the first part. Now the second part says use the pattern to write the nth term of the sequence as a function of n, meaning find the formula that gives you these terms, not recursively. So if A1 is 81, A2 is 27, A3 is 9, A4 is 3, and A5 is 1. This to me is the trickiest one. Let's see if you can spot it. First of all, I'm getting smaller, right? So whatever it is has to be getting smaller. And there's something happening with powers of 3 there because I go from 81 to 27 to 9 to 3 to 1. They're all something that's a power of 3. Yeah.
Is it possible to do cube root of it? No. It wouldn't work.
I mean, you could, but yeah, no, it doesn't. Let's say we start with the base of 3 because that's the common base, right? So let's say I start with 3 and I want to raise it to a power. What would I want to raise 3 to get to 81? 3 to what power is 81? 4. What would I want to raise 3 to get to 27? 3. 3 would be squared to get to 9. 3 to the first would be 3. And 3 to the 0 would be 1, right? Do we understand that pattern? So then how do I make the exponents come off of the number of term? What would I have to do to n if n is 1 to get to 4? Add 3. What would I have to do to 2 to get to 3? Add 1. So that does, I can't just add the same number, right? What else could I do? Yeah. 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4, 5 minus 5. Good job. Do we see that? If you're not going to be able to add something to it to make it get bigger, because I need to get smaller, then what can I do to subtract? Good job. That's not an easy one to spot. I don't want anybody to stress out because that was not an easy one to spot, but that works. So how do I rewrite this in an expression form? A sub n equals, they all had the base of 3, but the exponent has to be 5 minus n. And again, I'm not saying that that is the only way to do it. Somebody could figure out a different way to do this. But that does work to get me on my pattern. Questions? Okay, now we get into factorial notation. This is something that you should remember. Like this goes back to elementary, even if you remember it. Okay, and it is the exclamation mark. So if you see a number with an exclamation mark, like 8 exclamation mark, does not mean you just get to yell 8. Like 8, so exciting. That's not what that means, okay? That means you multiply that number by its, you start at that number, and then you multiply it times one less number all the way down until you get to 1. So if I had 5 factorial, that is like saying 5 times 4 times 3 times 2 times 1, okay? We're going to use these a lot when we start to get into probability, so it's important that you understand exactly what that is. There is a special case, and that is 0 factorial. 0 factorial is just 1, and that is not something you can figure out arithmetically, so you just need to know that. Memorize it. It's like knowing something to the power of 0 is 1. It's the same concept. Good point. Yep, you can keep going, but the number will just get smaller and smaller and smaller and smaller and smaller. Good. Okay, but if you memorize it, it's like I said, it's like knowing 3 to the 0 power is 1. It's one of those things that you just want to memorize that will make your life easier. So 0 factorial equals 1, okay? So you will see them built into your terms like this. Write the first 5 terms of the sequence. We're going to just do 3 so we catch the point and would not kill ourselves with time. We're going to find the first 3 terms. So A1, A2, A3. Everywhere there's an n goes 1. So 1 over 1 plus 1 factorial becomes 1 over 2 factorial. And 2 factorial is what? Two times 1, which is 2. Then I do 1 over 2 plus 1 factorial. 1 over 3 factorial, which is 1 over 3 times 2 times 1, or 1 over 6. And then I do 1 over 3 plus 1 factorial, 1 over 4 factorial, which is 1 over 4 times 3 times 2 times 1. Now we know 3 times 2 times 1 was 6, so all you got to do is add in what you just did the last time, multiply it by 4, 1 over 24. Questions on that one? All right, example 8 says simplify the factorial expression. So instead of multiplying out 5, 4, 3, 2, 1, and 7, 6, 5, 4, 3, 2, 1, all you have to do, and this is like a shortcut, but you're going to use this a lot. What you have to do is take the bigger number. What? I get it. All right, so you want to find the bigger number. So in this case, 7 is the bigger number, right? And you break it down until you hit the smaller number. So I leave 5 factorial as 5 factorial. And in the bottom, I do 7 times 6 times 5 factorial. And then these are going to cancel. I get 1 in the top, and this is 1 over 42. So wherever the bigger number is, sometimes it's in the top, sometimes it's in the bottom. You take that one, you break it down till you hit the smaller one, and then you cancel. It says 1 over 42.
No, I mean like the 1 and then 5 exclamation mark. Oh, is that a 15?
No. This, I crossed this through and wrote 1. Like you simplified it. Okay, so B, what's bigger, n plus 2 or n? N plus 2. So if I did n plus 2, what's the next smaller number? N plus 1. What's the next smaller number? N. So I broke it down until I hit the smaller number, and these cancel. And I literally get n plus 2 times n minus 1. And you can leave it just like that. Let's say this is a standardized question. They may FOIL that out. You would know that by looking at your multiple choice answers. But if it's just open-ended, feel free to leave it like it is. Okay? This is summation. So summation, again, looks scarier than it is. It looks scarier than it is. It's that little, it's called a sigma. This is good college prep because fraternities, sororities use that little e. That's called sigma. That symbol is called sigma. Shh. Okay, listen. What it means is find the terms of the sequence, starting with the term number on the bottom, ending with the term number on the top, and then add them all together at the end. So if I had the sigma and the bottom said I equals 1, it could say I equals 1, n equals 1, k equals 1. The variable doesn't matter. And then the top says 3. That means I'm going to find A1, A2, A3, and then whatever I get from them, I'm going to add at the end. If it said 1 on the bottom and 5 on top, I'm going to find A1, A2, A3, A4, A5, and then I'm going to add them all together at the end, okay? The bottom number tells you what term to start at. The top number tells you what term to stop at. So if it said, if my sigma notation was 4 on the top and this said I equals 2, now I'm finding A2, A3, A4, and then I'm adding them together at the end, okay? So this, the number, this thing, because you're going to see terms like this, the I, which is like the variable, is the index. The N is the upper limit, so where we stop. So the one at the top is where we stop. The one at the bottom is where we start, okay? So see what this means now. Find the sum. What do we start at? A0. So we're going to plug in 0. Where do we stop? A3. And then you're going to add them together at the end. So, okay, so A0 is 0 plus 1 times 0 minus 2. Guys, which is negative 2. A1, 1 plus 1, 1 minus 2. 2 times negative 1, negative 2. A2, 2 plus 1, 2 minus 2. 3 times 0. And 3 plus 1 and 3 minus 2. 4 times 1, which is 4. And then we add them all together. Negative 2 plus negative 2 plus 0 plus 4, which is 0. So a summation can be, a summation can be positive, it can be negative, it could be a fraction, it could be a decimal. There's no rule about it, okay? So you could actually have a bunch of negative numbers and the sum of them are negative. There's no rule about what kind of number that can be, okay? Questions? Yes? There is a question that, I don't know what it says, like this, and then just in numbers here. Okay, there's a question that looks like this on the right. What would A1 be? 5. What would A2 be? 5. What would A3 be? 5. So if there is no variable, it is literally just what's there. You could literally just figure out how many terms there is. And that's your summation, okay?